Hello, this is checkpoint 2.4 from section 2.2, and they want us to estimate the limit as x approaches -1 of 1 over x minus 1, all divided by x minus 1, using a table of functional values, and then use a graph to confirm your estimate. Okay, so let's figure out using a table. And the idea here is to take this as a function and then put in values that are close to -1. So some values close to -1, this might help if you have a number line, and this is -1 over here. So values, this is 0 here. Values that are close to 1 coming from the left and the right hand side. Something on the left side would be something bigger than 1, or not bigger, but more negative. So that would be a negative, maybe -1.1 might work. And then we can get even closer, -1.01, and then maybe one more, -1.001. And then, so these are the points that we generally want to check. On the other side, we're coming from 0 to -1, so that would be like -0.9. -0.99 will get you even closer, -0.999. So these are the types of values that we want to put into the function. Now for this, I would probably want to, you can use Excel if you're comfortable with that, or you can type this function in, and you have to be very careful about using parentheses. You can type this in your calculator and create a table that way. Desmos has a nice way to create tables as well. So I created my table using Desmos. And so the idea is you want to put values in. So for example, for this first one, I would put, well, let's see, I want to write f of x is equal to 1 over x minus 1 divided by x minus 1. And then I want to compute -1.1, for example. So wherever I see an x, I will put -1.1, and and then try to find those values. And again, doing this one by one, punching in your calculator would be kind of difficult. Again, I would use a formula, or use this as a formula to put it in either your graphing calculator or Desmos, and then put in the value like -1.1, etc. So I got for this one not negative, I'm sorry, 0.90909. I guess it goes on forever, so it just stops here, and that's my first value. So let's just put 0.9091, just to round out the 4 decimal places. And then for the next one, without doing this computation, because like I said, I did it in using technology, I got I'm sorry, 0.990099. Well, I guess they put a 1 here just to round it off correctly. And then for the third one, I got 0.999. So if you could take a look at this and see, it looks like 0.9, 0.99, 0.999. It looks like it's getting closer and closer to +1. But we can confirm that. Let's go from the other side and see what we get. If I put in a -0.9, we'll get a 1.11111. Then I would get, if I put in -0.99, I would get a 1.0101. And then if I put 0.999 in, I'm going to get 1.0010001, etc. So it looks like coming from either side, it's closing in on 1. So I would probably want to use that as my guess. So estimate, I would probably say that the limit as x approaches -1 of this function will equal to +1. Okay. Now the second part, they want us to graph to confirm your estimate. And so again, we'd use technology. I graphed it, and I'll show you the graph that I have here. Well, it's backwards because I'm using the mirror image, if you haven't figured that out already. But the graph essentially looks like this. And we can think about graphing it. We can take a look at this expression and simplify it. If we simplify it with common denominators in the numerator, I'm going to get 1 over x minus x over x divided by 1 minus x. So this would be 1 minus x divided by x on top, and x minus 1. If I switch the order on top and take out a negative sign, negative x minus 1 over x, that's the numerator. I multiply by the reciprocal of the denominator. I get x minus 1 cancel, and then I'm going to get this to be -1 over x. So that's what this graph is, really. There's an issue at 0, but there's an issue at 0 anyways. In any case, looking at that, if we take a look at where -1 is in the graph, the x value of -1, we will get a y value of +1. So that kind of confirms what we had for our estimate earlier. So I hope that helps with the graph, with the numerical values and the graphical approach. And we also threw in some symbolic approach here just so we can graph it. But you can always rely on using technology to find some graphs for you. All right, I hope that helps.